Hello everyone, welcome back to the new project called Taxi Booking Application. In the previous video, we have discussed about the project Railway Ticket Booking Reservation System. Now in this video, we are going to implement a project called Taxi Booking Application. So these are the conditions to implement this project. Here are the sample inputs and outputs. So this is the project we are going to implement. I have already implemented this project, and this method is a new method, and no YouTubers use this approach. I have used Min-Heap for this project. Using a single Min-Heap, we can easily implement this. So let's get into the demo video of the project. So this is the main file. After seeing the demo video, I will explain all the steps, don't worry. This is the main page. We have only 3 options: book taxi, display taxi details, and exit. So once you hit 2, I am first printing the taxi details. So we have currently 4 taxis in our project: taxi 1, taxi 2, taxi 3, taxi 4. Currently there is no earnings in any of the taxis, and there is no booking. So I am going to book a taxi. I am entering customer ID 1, pickup point from A to pickup point D. Here asking the time when to pick up, 10 a.m. So here you can see taxi 1 is allotted. So we can also see the details. Here under taxi 1, the booked ticket is printed. Booking ID 1, customer ID 1, from A to D, pickup time 10, drop time 13, because we are going from A to D, and amount is 500. So if you see the question only, you will get it correctly. First, the point is design a call taxi application. There are n number of taxis. Note this point. We should not implement for 4 taxis. It should work for n number of taxis. For simplicity only, we are taking 4 taxis. Then there are 6 points, A, B, C, D, F. These are the points and the locations. All the points are in a straight line. The distance between each point is 15 kilometers. And it will take around 1 hour to travel from one point to another point. And minimum 100 is charged for 5 kilometers. And the rest of the kilometers is charged 10 per kilometer. For simplicity, we are going to use round numbers like 9, 10, 15, etc. We are not going to use floating point numbers because it will go complex. All the taxis are initially at point A. When the customer book a taxi, a free taxi at that point is located. Suppose the customer is booking a taxi for the position A. He is in position point A and he is booking. Now at position A there are 4 taxis. Any one of the taxis can be allotted. If the passenger goes from A to D using taxi 1, and the second customer books taxi in point D, means taxi 1 must be allotted because the taxi 1 is already at position D. Here is the condition, another condition. If there are no free taxis available at that point, a free taxi's nearest point is allocated. Just now I said this, from point D, taxi 1 must be allotted. If 2 taxi are there, if suppose at point D there are 2 taxis available, means the taxi which earned lower earnings compared to the 2 taxis will be preferred. Note that the taxi only charges customer from pickup point to drop point. This also I will explain clearly in Paint. Note that the distance it travels from adjacent point to pickup point the customer. Note, if no taxi is free at that point, booking is rejected. So now I will explain it clearly. Assume we have 4 points: A, B, C, D, and we have 4 taxis. 1, 2, 3, 4. The 4 taxis are currently in location A. 4 taxis are currently in location A. We can add 2 more: A, B, C, D, E, F. We have 6 points. Each point's distance is 15 kilometers, and from A to B it will take 60 minutes. That is 1 hour. Now a passenger or a customer 1 is booking taxi from point A. He is booking from point A to D. Let us assume the customer C1 wants to go from A to D. Now all the taxis are at point A, so we can use any of the taxis. So I am picking 1. So taxi 1 is booked. Taxi number 1 is booked for customer 1, and now the taxi is at point 1. The taxi picked the customer C1 and reached the point D. Now suppose another customer, let's say C2, is booking a taxi from D to E, C2. Now which taxi will be allotted? Here we have only 4 taxis. The first taxi is already here. Remaining 3 taxis. Generally, if these 3 taxis, 2, 3, 4, if we want to reach the point D, means it should cross A, B, C and D. 4 hours it will need to reach D to pick up the customer click. So the taxi is already in point D, taxi 1. So we can, and it is also completed the job. C1 to D, it has dropped customer C1 to D. So it is also completed its job. So now the taxi is free, taxi 1 is free. So we need to allocate taxi 1. Here also we need to allocate taxi 1 to the customer C2. Now the taxi 1 will be at position F. Suppose another customer is booking a taxi from C to D. Let's assume C to D. Now which taxi will be allotted? Now for first taxi is also free, 2, 3, 4 also free, but the distance to the booking point, here is the booking point of customer C3. Here is the customer booking. So if 2, 3 and 4 needs to pick up the passenger C3 means it will need to cross ABC 1, 2. It will take 2 hours to reach point C. But the first taxi will take 1, 2, 3. 3 hours it will need. So what is the minimum distance? 2. So we need to allocate taxi 2. So for this we need to allocate second taxi. So this is the approach. Another one case also there. Let's see now. The same thing. Let's say we have A, B, C, D. Now we have only 4 points. For simplicity, 4 points. This point is explaining this condition. Note that the taxi only charges customer from pickup point to the drop point. Suppose, let's say, another customer, the first customer booked taxi from B to C1, and we have 4 taxis. The first taxi is booked. Customer C1 is booking taxi from B to C. First taxi is allocated. The pickup time is 10. Assume the pickup time is 10. At 10 a.m. this customer is booking. And when will the customer reach C? 11 only the customer will reach C. Another customer is booking taxi from C to D. Customer 2. He is also booking 10 at 10 a.m. Now the taxi 1 will reach C by 11. Before reaching point C, another customer is booking from C to D. Now which taxi will be allocated? Currently taxi 1 is traveling from B to C and it till not reached C. But the passenger C2 is booking the taxi at 10 a.m. So the taxi 1 cannot be allocated. So the next taxi which is free is allocated. So taxi 2 will be allocated. So this is the complete conditions we are going to implement. So now if you see the program means you will understand. I'm going to end and starting from the beginning. So here is the sample test case. Let's we implement this in the demo. So customer 1 from A to B, point A to B at 9 a.m. is traveling. So taxi 1 is allotted. Customer 2 from B to D. So already the customer is previous customer is dropped at B. So taxi 1 is free now. Now the customer 2 is also needs to go from B to D. So pickup time also 9 only. This customer also booking the taxi at the same time. So taxi 1 is now currently traveling now. So taxi 1 cannot be allocated. Taxi 2 is allotted. So like the same way, customer 3 is allotting a taxi from B to C. Now at the later time only he is booking the ticket 12. So here 9 B to D means 2 hours it will take to complete this job. And this also A to B means it requires only 1 hour to do this job by taxi 1. So now taxi 1 is free because this ticket is booked in 12 a.m. So taxi 1 is allotted. So this is the booking details. Once we display what are the taxis booked, how much it takes charge, and total amount earned by the taxi. So let's see it in the demo. So currently there are no bookings. Now I'm going to book based on the demo output we saw in the website. Customer ID 1, pickup point from A to B at 9 a.m. So taxi 1 is allotted. And then the second customer B to D, same time 9 a.m. Taxi 2 is allotted. And the third customer from B to C 12 a.m. So taxi 1 is allotted. If we print the result means we can see the same output as that is shown in the website. 400 total earnings because taxi 2 is booked 2 times, A to B and B to C. So the total amount is 200 plus 200, 400. So this is the project. Once you hit 3 means it will exit. I have used Min-Heap to implement this project. So let's roll into the coding part and I will explain line by line. Sorry guys, I forgot to explain this condition. If the 2 taxis free at the same point, one with lower earnings is allotted. So let's see this condition. First, a taxi 1 is allotted for a person from A to C. Taxi 1 is now at C. And taxi 2 at the same time, taxi 2 is also allotted to another person. This is for customer 1. This is for customer 2. Now, another customer, new customer is booking from taxi C to D. Customer 3 is booking from point C to D. Now, both taxi 1 and taxi 2 are at point C. Which taxi will be allotted? Both are at the same point and the minimum distance is 0 because they are already in point C. Right now, and the amount of earning comes here. The taxi T1 is traveling from A to C, which means 15 kilometers from A to B, 15 kilometers from B to C. Total 30 kilometers. How much? 30 kilometers traveling. First 5 kilometers. First 5 kilometers we will charge 100 rupees. The next 25 kilometers we will charge 10. Then 250. So if we add this, we will get 350. So the taxi 2, which is here, the taxi 2 taking the passenger seat to from B to C, which is just 15 kilometers. This is for taxi 1 calculation. For taxi 2, T2. From B to C, it will take just 15 kilometers. Easy calculation. First 5 kilometers we are charging 100. And the remaining kilometers we are charging 10. So 10 kilometers into 10, 100. So here we are getting only 200. So the minimum is T2 because the taxi 2 is having minimum amount. So taxi 2 is allotted for this. We need to check the previous earnings also. This is for the current trip 200 and 300. We need to also check the previous trips. Combining by adding all the trips, which taxi is getting lower earnings, that taxi will be allotted. So this is the condition. So let's get into the video. Right, coding part. First, I am including all the necessary libraries, and in the main function I will always keep the code minimal. I will not write all the codes in the main function, so that the new learners and beginners will not get confused. So I will call the necessary functions only in the main function. So I am here creating a vector to store the taxi details, and I am initializing the taxi class. I am initializing the taxi class and customer class also. Here I am importing the two classes. I have written separately classes for taxi as well as customer. Now customer class will store only the customer details. Taxi will store the taxi details like how much it earned and what is the current position the taxi is now, and whether the taxi is currently having a trip or not. These are the conditions we will store in the taxi class. Now we all know that this is I have already explained this in the previous video. Until we press the exit button, which is we are setting the exit button as 3. First, at beginning our display options is displayed. So these are the options. Once we press 3 means we will exit the program. Until that we are looping and printing the display options repetitively. Okay, let's see the choice 1. So choice 1 is book taxi. We are going to book a taxi. Before that we are going to see the taxi class and customer class. So first we are going to see taxi class. So in the .h file we will store only the body of the taxi class. We are not going to write anything inside the member functions. We are just declaring. So taxi number, current location where the taxi is now, total earnings, and this is job ending time, means whether the previous booking is completed or not. Job end time means suppose taxi 1 is booked at 10 a.m. and it will need to travel 3 hours, means it will reach by 13 like 1 a.m. If we book the taxi in at 7 a.m. means it will need to travel suppose 3 hours, means 10 a.m. only it will reach the destination. So we need to update job ending time as 10, so that only we can check this condition before allotting the taxi 1. So this is the initialization. Setter functions and getter functions all we know. This is going to set the values we pass. This is going to get the values. In taxi function we have 3 functionalities: generate taxis, book taxi, and print the taxi details. Generate taxis means we see in the question will work for n number of taxis. So here I am declaring I first itself declared total taxis 4. If we change the number 4 to n number 1000 taxis also, it will work definitely. Then customer class. In the customer class also, it will store these details like in the output we see booking ID, customer ID, from, to, pickup, drop point amount. These are the details stored in the customer class. Same as getter functions, setter functions. Sorry, these setter functions, getter functions. And here mainly we have two functionalities. If the customer is successfully booked to a particular taxi, means we will add the customer to the details list, and this is for printing the details. So this is the class definitions for the taxi and customer class. Now once we press option 1, which is book taxi, it will call the book taxi function, which is located in the taxi class. So here is the book taxi. I have only declared the body of the book taxi, which is it will getting the parameter as taxis. In these taxis, there are 4 taxis because we generated only 4 taxis now. First, before calling the option 1, here itself we have generated the taxis. Once I call this function, means it will generate the number of taxis we have declared. So generate taxis class we can see now. Really generate taxis function. So as you can see, the taxis list which we are going to store the generated taxis, I am getting as a reference. If we get the taxis vector as a reference, means only it will store the taxis permanently, otherwise it will not store it. So for I equal to 1 to taxis, total taxis, we are creating a taxi class and setting the taxi number as 1, 2, 3 and 4, and we are pushing the taxis into the taxis vector. That's it. This is the generate class, and once we call this function, means 4 taxis will be generated. After, if you are going to book, means in the book function we are passing that 4 taxis. Now we have generated 4 taxis. That 4 taxis is passed to the book taxi class. So I'm going to call book taxi. Here is the book taxi function. I will close all these functions and I will explain only the book taxi function. So here is the book taxi function. So here is the Min-Heap I am using. This is the main thing in this total project, because we need to allocate the taxi by applying all the conditions in the question. So what are the conditions? Means the taxi must be nearer to the point where the customer is calling the taxi, like pickup point. The taxi must be nearer to the location, and the taxi which must be having minimum amount. If suppose 2 taxis are at the same point, we need to call the taxi which has minimum the 2 conditions. So I am using a Min-Heap, which will give, if I take the top element of the Min-Heap, it will automatically give the taxi which is nearer to the person and also having smaller amount, lesser earnings. It will automatically give. So using this we are going to implement. First, I have created a priority queue, that is Min-Heap, and I am getting all the details: customer ID, pickup point, drop point, pickup type. And now I am going to take from the 4 taxis. What is this taxis list? We have generated 4 taxis now. That 4 taxis is passed as the reference. Now I am going to loop through the 4 taxis using for loop, and I am going to get what are the possible taxis we can allot. Suppose 2 taxis may maybe at the same point, like where the customer is booking. So only we are looping through all the taxis and pushing to the priority queue to filter the most preferable taxi. Like distance also we need less distance, and amount also we need to have a lesser amount, so that only we are iterating through the 4 taxis. And first we are calculating the distance. What is this distance? Means how much distance the taxi is far away from the booking point. That is the distance. Distance equal to taxi dot get current location, means it will get the current location of the taxi. Suppose we say it is from B. The first taxi is at position B, minus from means pickup point where the customer is booking. So if the taxi is in B and minus the taxi should come to B. So B minus B is 0. So the distance is 0, which means the taxi is at the same position where the customer is booking. So this is the distance 0. So taxi dot get job ending time. So it will give the previous job ending time. Like taxi 1 is in B. No. In the before travel, when will the taxi will end that travel? It will give. So suppose we are assuming that the taxi has already completed the previous job. Now the time is 10. Okay. The taxi time is 10. At 10 a.m. the taxi is completed its previous job, plus distance 0, less than or equal to pickup time. If the person is giving the pickup time as 10, okay, 10 a.m. means the taxi can come to the distance at 10 a.m. So this taxi is one of the possible taxis. So we push that taxi into the Min-Heap. While pushing, we need to push distance and current earnings of the total earnings of the particular taxi and the taxi full taxi details. We are pushing like this format. To explain how this Min-Heap works, if you are not get it clearly, means watch it. I will show it in the Paint. Otherwise you can skip this part. Now we have 4 taxis and point A, B, C, D, E and F. 4 taxis. 1, 2, 3, 4. And our priority queue is here. Min-Heap. Let us say as Min-Heap. Min-Heap. This is the main functionality for our project. It is picking the taxi, which taxi we need to allocate for the particular person. So first I'm checking the 4 taxis. Initially all the 4 taxis earnings is 0 and the distance is A. Okay. So running this for loop, initially first iteration, the distance for all the taxis is 0 because current location is A and from location is suppose the customer is booking point A means all the taxis distance is same. So let us assume customer C1 is booking from A to B at time 10. We are getting these details from you pickup time, all we get from the user. And now we are going to check the possible taxis we are going to allocate. Running the for loop and checking the distance. What is the distance? Taxi dot get current location minus from. Okay, taxi dot get current location. First taxi we are iterating. Current location A. For first taxi, current location A minus from location where the user given from location A. So distance equal to 0. For taxi 2, from location current location A, from location also 0. So the from location is the one location the customer is booking. The customer will give the from and to address, no, pickup location. That is this. This is the current position of the 4 taxis. So all will come 0. So we are checking distance we have calculated, and we need to check this condition also. This condition, if this satisfies this condition only, we will push the taxis into the min heap. Taxi dot get job ending time. The current job ending time will 0 plus distance also 0. So 0 plus 0 is 0, less than or equal to pickup time. Pickup time I am assuming 10. So this is the distance. This is distance, no. Distance, these values plus current job ending time of the particular taxi. Taxi 1 job ending time 0, which is equal to 0. So for all the taxis, it is satisfied this condition. This condition we have satisfied. So we are going to push all the taxis into the min heap. Pushing taxi 1, taxi 2, taxi 3, taxi 4. The min heap will now sort the taxis. Which taxi we are going to allocate, it will sort. For sorting, we are using, we have pushed all the 4 taxis using this loop. And now, if no taxis meet this condition, then automatically we are out of taxis, no taxi available, and we will return. Otherwise, if we once we pushed the taxis, it will automatically, this priority queue will sort the function, because we implemented sort, compare, custom comparison here. So I have written custom sorting. So min heap will actually do the top element as minimum value by default, but I am overwritten that default function here. So using compare function, I am getting in this parameter taxi 1 will be passed. Let's say here 2 taxis, it will compare at a time and it will sort. First iteration, first it will compare T1 and T2. Okay. Or let's say first it will compare sorry, I had done a small mistake. Wait. 1, 2, T4. So first it will compare T1 and T2. Okay. Here we are getting A as T1, B as T2. So in this manner we are getting. So we are storing in this format now. Distance, amount, taxi. So here also we can store distance, amount, taxi. So I am deleting this. Wait a minute. Distance and amount and taxi. We need to store in this format. Distance, amount, taxi. Distance, amount, taxi. Distance, amount, taxi. Distance, amount, taxi. So this is the format first in the first iteration, the first booking. It will store in this format. Our Min-Heap from will give the sorting, custom sorting based taxi. This function will sort our taxi, that is which taxi we need to allocate. If we now if we now get the top taxi, means now the taxi T1 is at the top. So here you can see after pushing and here checked there is no taxi, means we will return, otherwise there is some taxis available. So we are getting the top taxi because the Min-Heap will automatically give the top taxi which needs to be allocated. No, so it will take the top taxi T1. So first T1 will be allocated. T1 is selected. No, T1 is allocated. T1 is selected as the booking taxi, and we are initializing the customer details. We have bought all the details here and we are going to set to the customer class using the instance object C. So we are setting all the details, and once we allocated for the customer IDs 1 for taxi 1, means we need to update the taxi amount with AND. So I am done. I'm calculating the amount here, like first 5 kilometer 100 rupees, and the remaining we are minusing the 5 kilometer from the total distance, and the remaining distance cost 10. So this is the amount. We are going to set this amount to the current taxi. So this is taxi ID of 0, because we are getting the ID of the taxi using this line. Filtered taxi dot top means this will come. This entire thing will come, and the taxi ID is available in the T1 instance, that is T1 dot get taxi number. So top means it will get this, and top of this is one pair, this is one pair. In this format only we are storing. No, so this is first, this is second. So we are accessing top dot second dot taxi number, means we will get that taxi number. So using this ID we will update the taxi current earning and current location, set location. Now after completing this job, the taxi location will be B. We will want to update the current location of the taxi to B and set job ending time. This is important. When will this taxi will finish its job? 10 it is pickupping, 11 it will end. So we need to put here 11. Update the set job ending time as 11, and we are going to add the customer details to the booked customer list, which is in here we are adding. Here we are adding. This is the details and we are calling this function add book details. Here just we are adding the booked details. Here also we are creating a vector for storing the details. In this detail we are pushing that store details, and for printing we are looping through the booked details and we will print. So this is simple only. So I will make sure to explain this part clearly. This part. So now we have successfully booked taxi 1. Okay, this is clear now. Taxi 1 is booked for passenger 1. Now another taxi will be booked if a passenger tries to book from. Wait, I am clearing. Okay. Now another person is trying to book. B2 D. Already T1 is booked. Okay. And B2D is now booking. Customer C2 is booking at 10 a.m. He is also booking at 10 a.m. So we are putting here 10. And now we will loop through the taxis. And what are the possible taxis we can allocate to this person? We will see now. First we will get the first taxi. We will loop through the all available taxis. So C1 is also taxi 1 is also one of the available taxi, no? So we are first getting the taxi 1. Okay, wait, I will empty this also. So again, or max heap will be, min heap will be created. This is for operation 2 for booking next taxi. First, using this loop, again we are generating the possible taxis and pushing to the min heap. So we do. Okay, first taxi. We need to check this distance. We need to calculate distance. So what is the distance? Distance formula. Current location minus from location. From location here is B. Current location of taxi 1 is, I have said that taxi reached B. So current location is B minus from location is B. Then the distance should be 0 for taxi 2. Current location is taxi is still in A. It is not moved yet. But from location is B. So A minus B in C++, absolute of A minus B means the difference is 1. So distance is 1. For third taxi, which is also A minus B, which is 1. So for fourth taxi also the same will be there. So I am not going to calculate this. So after calculating distance, what we need to check? Taxi dot get current job time plus distance. That must be less than pickup time. So this is distance plus we need to plus add the distance with job ending time. We know that taxi 1 will end at 11 a.m. So we need to put 11. Okay. Then For remaining, it will remain 0 only, because these taxis did not book it. So total distance is 11. Now let's slightly change one thing. The passenger C2 is not booking at 10 a.m. 11. At 11 a.m. only the customer C2 booking at 11 a.m. Okay, because at 11 a.m. the taxi A will reach B. Now in the Min-Heap we will push only the past taxis. The total distance will be less than pickup time or equal to. So the pickup time will be 11. So these all are less than 11. Now we will push again all the taxis in the form of first taxi we are pushing distance 11, amount and the first taxi will earn certain amount. How much it will earn? From 15 A to B 15 kilometer, 5 kilometer 100, 10 kilometer 100, 200 amount it will earn, and T1. Then again all 0, 0, T2, 0, 0, T3. The Min-Heap will return the sorted order of the distance. This distance, wait, while pushing we will add only the distance, not the distance plus get job. So here will not come 11, because distance is only 0 no for taxi, 1, 1. So 0, here it will come 1, here also it will come 1. So the Min-Heap will sort based on the first distance. It will sort. First it will sort means taxi T1 will come. Again this also same, T4. First it will sort using the distance. By using the distance it will sort means 0, 1, 1, 1. The same will come. Then again it will going to sort using if the first location like distance is same with another taxi means only it will sort using the second amount. We have implemented this here. See, if A dot first means first taxi's distance not equal to second taxi's distance. So if this condition true only, we will go for the if the see here first taxi is T1, second taxi is T2. Both the distance is not same, no, 0, 1. So we will get into this. We will sort ascending order in ascending order. So A dot first means 0. In our case 0. B dot first means 1. 0 greater than 1, which is false. If it is written false means we need not to swap these two values. So T1, T2 remain same. And after it will take T2 and T3. Now 1 and 1 both are same. Now this condition will take A. If both are same means we will sort by the amount section, that is second. A dot first dot second means 0. B dot first dot second means 0. So 0 greater than 0 false. So we need not sort. T2 and T3 are again at the same location. 0 I tell means this 0 amount. So again also at the top taxi T1 is there. Again also at the top taxi T1 is there. So again also we are going to allocate taxi T2 for the second travel also. Okay, let's book one more taxi and we updated. No, sorry, taxi 1 is booked. Now we are going to update taxi 1 details, that is current location as D and ending time, job ending time 11 plus 1 2. It will start by 11 and end D by 13. So 13. Now let us book one more ticket and in this video you will get clear. So again here is the Min-Heap. So now again a customer is booking from B to D at time 12. So again we are going to loop through the taxis and finding the possible taxis. For first taxi and distance is, we are going to calculate distance formula, current location minus from. Current location of first taxi is D minus from location is B. So B, C, D, the difference is 2, distance is 2. Second taxi, for second taxi current location A minus B, so distance 1. Third taxi A minus B, distance 1. So fourth taxi also same distance only, A minus B, distance 1. Now distance plus we need to add the job ending time. What is the job ending time? Because we need to check this condition, so that only we will push that particular taxi. Job ending time means we have previously seen job ending time for taxi A is 13. So 13. These are 0 because these taxi is not involved in any of the travel yet. So these values should be less than pickup time, less than or equal to pickup time. Our pickup time is 12. So it is not less than 12. Taxi 1 won't be updated. So these 3 taxis will be pushed to the Min-Heap. What is the format we store? Distance 1, amount and 0. These 3 taxis never and any amount, and the taxi instance T2. So we are going to update like this format: 1 0 T2, because T1 is not meeting our requirement, so T1 will not be updated. Other all taxis will be updated. 1 0 T3, 1 0 T1, T2, T3, T4. Now again it will start using the first value. So all the values are same. Same means what? We need to check for the second column. Amount also all same. So no swap will be performed. The list remains same. So we will allocate for T2. So this ticket will be allotted to taxi 2. In this way only the taxi is filtered from the Min-Heap and gets allotted. So I used Min-Heap to easily pick the taxis from the possible taxis and to get allotted. So after this, the second option is taxi details. We are printing the taxi details now. Let us see the taxi details method. Here it is. So we are getting the taxis, 4 taxis as parameter, and we are basically loop through the taxis and printing using the getter method. We are getting the values, total earnings, taxi number, and we are calling what are the passengers currently booked under the taxi, under the particular taxi. Then we are passing that particular taxi to the print custom details. So here is the class. Then we are looping through all the booked details, and whatever details matches with the current taxi, it will print the details. Now, to understand it more clearly, see this one step only. Okay, now we have booked customer 1, customer 2 and customer 3. 3 tickets we booked. Taxi 1 takes 2 and taxi 2 takes 1. And now both the taxis are at location D. So this is the special case. So now the taxi 2 is also booked. And current location of taxi 2 is D. And ending time for taxi, this is ending time. That job ending time. Job ending time of taxi 2 is, it is starting at 12 and ending, because it is picking at 12, 12, 13, 14. It will end by 14. And how much amount taxi 1 and taxi 2 earned? Taxi 1 earned from A to B and B to D. So if you calculate, means it will come 400. Taxi 2 earnings will come around, because it is traveling from B to C 15, C to D 15, 15 plus 15 30, so 350 it will come. Let us calculate. 30 kilometer means first 5 kilometer it will take 100, then 25, okay, correct, 350. Okay, now we are one customer is booking from location D to E or D to F. What taxi will be allocated? Because we know that taxi 1 is also in location D, taxi 2 is also in location D. So we have and we have also possible chance that 3 and 4 also get that booking. So let's try out the Min-Heap. So carefully listen. For the first taxi, I am calculating distance. You need to concentrate more on this part, this filtering part. So distance fine and current job ending time, and both if you add means it should be less than pickup time, so that only it is one of the possible taxis. Okay, distance we are going to calculate now. What is the formula? Current, what is the current location of taxi 1? D. What is the pickup location? D. So 0. Distance 0. Second taxi also current location D. Pickup location D. 0. Third taxi current location A. Pickup location D. A to B B to C, C to D. So 3, 4th A to D, 3. So this is the distance plus job ending time. Job ending time is here 13:14 for taxi 1 and 2. 13:14. Remaining taxi is 0 only. Now what is the pickup time for D to D? I haven't shown that. I haven't included that. So let us keep the pickup time is 15. 15 means you convert into normal time. This is railway time. 12 means 12, 13, 14, 15, 3 p.m. 3 p.m. Okay, this is not necessary now. 15. The pickup time is 15. So all the details are less than 15. So this satisfies this condition. This condition. If we plus ending time plus distance, it is less than pickup time. So we are going to push all these taxis to this. So pushing format, we know distance. So first distance is this is the distance. First this is ending time. First taxi 0 distance. Amount 400 it and here is this. Here it is 400. And taxi instance T1. Because we are storing in this format in the priority queue. You see distance amount 1 pair, another 1 pair, taxi also included. Again another taxi 2, it and 350 T2. Distance to no earning T3. Distance to no distance 3. Sorry. Distance 3, 0, 3, amount T4. Now the Min-Heap will sort first using the first distance. Distance it is already sorted 0, 0, 3, 3. It is already sorted. Now if we take first 2, 0, 0, it is already sorted. So again we need to sort using the second amount. So this comes the interesting point. If you sort using the second, the new list will become like this. The heap will become like this. It will get swapped because we are going to arrange this in ascending order. So it looks like 0, 350. Taxi 2 will get first T1, T2. And then again 0, 400, T1. Here also the remaining 2 will come same like that because there is no change in this. It is not copying. Okay, leave it. 3, 0, T3, 4, 0, T3, T4. Here also 3 only. Okay, this is the new list we got for first. And now The top one is what? T2, because it has lower earnings. Distance is the two taxis. Which taxi will be allocated? The two taxis T1 and T2 are at position D only. But the money for taxi T2 is less than T1. So the first taxi T2 is taken out of the Min-Heap using this. Here we are getting no filter taxi dot top means T2 will come. Taxi number means taxi number 2 will come. Using this we are going to update the details respectively. So for this taxi 2 is allotted. So this is the whole project, and I have separated all the codes in separated class files. This is the main file. Once I will show you the code. So that you can refer it. So thanks for watching this video, and the video goes more long. So anyway, I hope that you understand the taxi booking system clearly. So make sure to hit the like button.